of the problem to balance out correctly. The next thing we're going to do is give the flow rate, okay? So it was 15 units per kilogram per hour, okay? And this is how it's written in the problem. So when you put your units across from, you're going to keep both of these because now we're getting ready to balance out our weight right here. We're going to be able to cross that out and be left with hour because remember what we want is milliliter per hour. So we have our 15 units per kilogram per hour, then we have our patient's weight, and all that comes out to 17.7 milliliters per hour. Okay, and so that's a large amount, larger than what we've been working with. It's still a small amount, 17 milliliters, but remember it's going in a big bag of solution. So never would that be given like sub-Q. Okay, all right, let's look at another one here. Okay, provider orders infusion begin at 16 units per kilogram per hour. There again, you see that. You're going to know that both of these are going to go next to each other on the bottom part of the equation. The patient weighs 88 kilograms. Pharmacy supplies it pre-mixed bag 20,000. Let's look at the milliliter per flow rate. So we were given 500 milliliters per 20,000 units. And then the flow rate, 16 units per kilogram per hour. Let's get rid of the patient's weight and get that calculated in. When we get all of it multiplied out, it's 35.2 milliliters per hour. Okay. Here, we're going to calculate not milliliters per hour, but units per hour. Okay, so careful when you're reading the directions. Are we looking for milliliter per hour? Are we looking for units per hour? It's done just a little bit differently. Okay, take a minute and read that. Okay, let's set up the equation. Again, we're looking for units per hour. We were given that there are 20,000 units and 500 milliliters, or 500 milliliters, and 13.7 milliliters per hour is our flow rate, and that calculates out to 548 units per hour. This one's a little bit more simple. Okay, so you're back down to your units per hour. Let's look at another one here. IV pump is going at 10.2 milliliters an hour. The bag hanging has 40,000 units. Calculate the units per hour flow rate. So again, units per hour, we're looking at 40,000 units over 1,000 milliliters, and we are given a flow rate of 13.2 milliliters per hour, and so that turns into 408 units per hour. There's something I wanted to share about that. Yeah. I'll think of it later and then post it. Okay, let's keep moving here. Now, let's say that we had some lab tests and they come back and it's looking like the patient is doing well, the lab values are getting to where we want them to be, and the doctor wants us to decrease the rate. And or the opposite, the values aren't where they need to be, and the doctor wants us to increase the rate. This is a very simple calculation, but really important to pay attention to how we do this. So, if your heparin flow rates need to be adjusted, then we determined a couple of things here. Is before we do that, the IV pump is infusing heparin in units per hour or milliliters per hour. It'd be really important to note, is it units per hour or milliliters per hour? Increasing or decreasing that flow rate when it's units per hour just requires us to add or subtract the dosage, the new dosage, to what the current flow rate is. Okay? When it's milliliters per hour, it requires additional information. The concentration, number one, of heparin in the bag, the current flow rate, what's it going at now, and the prescribed increase of heparin or decrease. And so changes should be documented carefully on that flow sheet so that the next nurses and staff will know exactly what's been happening. And this is a sample of a heparin flow rate chart that you would chart this information on. Okay, so let's look at an example here. Okay, we have heparin infusing. It's been going to 800 units. So in this case, it's going in units per hour. According to the protocol, it should be decreased by 100. So the IV pump should be programmed to what new flow rate? Well, it's real simple and straightforward. You take your current flow rate, which was given as 800, and we just subtract 100 to get your new one. Pretty self-explanatory there. Okay, but let's look at this one. This one wants it increased, and that's the key, is to make sure you're looking at the wording of it. So a patient has a continuous heparin infusion run at 14.5. Again, this time we're dealing with milliliters per hour, not units. The heparin should be increased though by units. So we got to do a little extra calculation here. So let's find out what the new milliliter per hour flow rate. We're going to round it to the tenths. So we're looking for milliliter per hour rate increase. Okay? So you'll want to write that in so you don't forget what you're going to do once you find this out. So we were given that in 500 milliliters there were 20,000 units. The increase that they want is 200 units per hour. So what kind of increase that can be? It's going to be an increase of 5 milliliters. And then what do we do with that? Well, we take the current rate and we just add that 5 milliliters, and that will give you your new milliliter per hour rate. So again, just be really careful when we're talking about milliliters. Okay? You all have lots of examples in your book as well as your post-test that you should be working through, so I kind of pulled out the practice ones here. But again, I'll have a video this week. We'll do live session for any of those that you're struggling with, okay? Low molecular weight heparin patients who are on this do not necessarily need routine laboratory testing. Like the doctor will have them come in every so often rather to check that, but it doesn't have to be extremely routine unless you're dealing with people who are pregnant, severely obese, or maybe have kidney impaired functioning. Your unfractionated heparin, that's the larger molecule, can be monitored using 2 different types of laboratory tests. Your APTT, it's activated partial thromboplastin time, and your heparin anti-factor XA, which will be discussed a little bit later. It's also an expensive test, not done that often. Okay, oh, sorry. Nope. Okay, so PTT measures the time it takes for a clot to form after chemical reactants or reagents have been added to that blood sample from the patient. Time it takes to clot. We're looking at the clotting factor here, and are we reducing a high clotting factor? So normal values range from about 25 to 39, different at different facilities. You would have to see what your facility values as those ranges. But since the purpose is to extend the patient's clotting ability, a lot of times the doctors will want that value to be even 1.5 or 2 times the normal value. Okay, the anti-factor assay test, this test measures heparin concentration in the person's blood. Okay, and that's a much more complicated test and costs a whole lot more, so it's not always commonly used. Takes a lot longer. Okay, well, is that it? And that is it. So again, if you have any questions when we have our live service, be sure to ask those questions, or you can email me at any time. Practice, practice, practice. I have made a 3-page form that breaks down how to do these problems, or gives you examples under each title with these steps. This is how you do this problem, step 1, step 2, step 3. I'm going to send that out to you all so that you'll have that as you're practicing these problems. But again, when we do live session, be sure that you've read your chapter and practice the problems, because I won't have time to reteach all that. We're just going to try and hit ones that you're struggling with. Okay, you guys have a great afternoon.